Hello, welcome to tutorial 7, Software Maintenance and Observer Pattern. For question 1, when screen arrives or leaves, GES will notify processing plants. The processing plants can register their interest in specific types of greens. GES will notify the registered processing plants using the plant preferred communication means, including email, SMS, or the combination of these means. Note that the interest and the preferred communication means of the processing plants vary greatly, and the processing plants can change their interests and preferred communication means over time. Furthermore, GES should be easily extended to support new communication means once they become available. Please identify the design problem in this feature and suggest a design pattern for addressing this problem. Illustrate your solution in a class diagram, map this class diagram to Java code skeleton, add implementation details as necessary. So now let's see the design problem. We can identify the following problems. First, we do not want tight coupling between GES and the registered processing plants. Secondly, we need to propagate the green information to plants immediately once green arrives or leaves. Thirdly, we do not know how many processing plants need to be updated and what these processing plants will do with the changes in the green states. So according to the identified problems, we can see that actually observer pattern is able to be used to address this problem. So for the basic observer pattern, it's like this one. We have subject and we have observer. The observer will register itself in the subject through attach and remove itself from subject through detach. And the subject can call the notify operation to update the observer regarding the data change. And we have the concrete subject extend the subject to implement the notify function. And we also have the concrete observers. So for the GES feature, we have this class diagram. We have the silo publisher, which is actually the subject, and we have the silo subscriber, which is the observer. And in the silo publisher, we have subscribe and the notify. Subscribe which used to register the observer, and unsubscribe used to unregister the observer. And notify is used to update the observer regarding the green changes. And we have the silo manager, which is a concrete subject. We have two operations, ship in and ship out, once the green changes. In both of the operations, we need to implement the functions like update the silos, and we need to generate a message, and we need to call the notify operation to send a message to update the observer regarding the change. And in the silo subscriber, which is the observer, it has a message send. It has an operation send a message, which is corresponding to the observer's update function. We have two concrete observers, email and the SMS. They both have the send message operation. In email, the send message need to implement generate an email with the given message and send to the given URL. And in SMS observer, it need to generate a short message with the given message and send it to the given phone number. So now let's see the code skeleton. For the silo publisher, which is the subject, it has a list of registered observers, which are the plants. And we also have a method called subscribe to register the observer, and unsubscribe to remove the observer. And we have a method called notify, which is to to update the green changes to the observer by called send message. And for the concrete observer, it has the two methods, shaping and shapeout. For we just use shaping as an example. In the shaping, it need to update the cellular information and aim to generate the message and then call the notify operation. And for the observer, it has declared a method called send message. And for the two concrete observers, email and SMS, they both need to implement this method send message, and according to the previous class diagram. For question 2, the egg timer program counts down seconds given to it as a parameter and dings or beeps when time is up. More specifically, the egg timer program must take a single integer value on the command line. It must interpret this value as the number of seconds to count down until ding or beeping the computer. The egg timer program must display the number of seconds left as it counts down. The first version of the program must display its output on the command line. Later versions must open a GUI window and display the countdown there. Consider 3 alternative designs for the egg timer. Evaluate these alternatives with respect to encapsulation, coupling, and cohesion. Which would you judge as the best? Can you think of an even better design alternative? Okay, now we can see that we have 3 alternatives. So for alternative A, it uses a pulse class to to notify the egg timer class every second, and the egg timer calls time display show to display the number of seconds left. The time display dings or beeps the computer when seconds reach 0. So for alternative B, it replaces the pulse class with the timer class, and the instance of the timer class called the run operation in the timer task object at regular time intervals. In this design, the run operation in the egg timer calls the time display show to display the time. In alternative C, it returns the class like a timer and a timer task, but it changes the way that the time display class works. We can see that the egg timer is a subclass of subject. A subject class keeps a list of observing objects. Every time it notifies observers, operation is called. It calls every observer's update operation. When egg timer begins, it will create a time display object and add it as an observer of egg timer. When egg timer run executes, it calls notify observer, which in turn calls time display update. This operation calls egg timer get second to get the time left and display it. So now let's compare A, B, and C. From the aspect of encapsulation, for A, because the egg timer needs to know the exact operation in time display, and the pulse needs to know operation tick in egg timer, so actually it's a bad encapsulation. And for B, the egg timer manages time decrement by self instead of being called by pulse, so it's a better compared with A. For C, the egg timer completely ignorant of time display's internal working, so it's the best one. From the aspect of coupling, for alternative A, the egg timer, time display, and pulse, they need to work together, so it's a tight coupling. And for alternative B, because there is no pulse, so actually it's a better coupling than A. For C, it's the most loose one. It can take out the time display and slow in other observers. From the aspect of cohesion, we can see that for alternative A, the egg timer has a responsibility also for display, so actually it's a bad cohesion. For alternative B, egg timer manages time decrement by self instead of being called by pulse, so it's a better cohesion. And for alternative C, the time display totally responsible for its own behavior after notification, so it's the best one. So according to the comparison results, we can see that alternative C is the best. Actually, alternative C is the observer pattern. In this alternative, we have two observers. Firstly, timer is a subject interface, and it's also a concrete subject. And the timer schedule is the subscription method. Timer task is an observer interface, and the timer task run is the update method, and the egg timer is a concrete observer. And on the other hand, subject is a subject interface, and the egg timer is the concrete subject, and the observer is the observer interface, and the time display is the concrete observer. So to achieve a better design, if egg timer can read the number of seconds remaining to database and the time display retrieves it for display, then egg timer and the time display can be totally decoupled.